Donut Lab announced their solid-state battery at CES, and I had the chance to talk with their chief technology officer. Now he is in the lab, revealing test results to prove wrong those who do not believe. In this video, I am going to break down the details of the report. The report was not intended to reveal everything because Donut Lab will release more information later on their new website. One thing is certain. Donut Lab has become one of the most interesting e-mobility stories of 2026. You might love them or you might call them a fraud, but in the first 2 months of this year, there has been a lot to discuss and research about what exactly is going on inside this company. So let's take another look at Donut Lab and examine the certified test results for their charging performance. This test and the following tests were conducted at the Technical Research Center of Finland. Most of Donut Lab's battery development work is being done in Finland. The report itself is written in English. As far as credibility is concerned, there is no obvious reason to believe that a government-owned research laboratory would fake results and attach their name to it, so that is a good starting point. This report focuses on charging performance to prove their claims of safe, ultra-fast charging. The tests include charge cycle results and measurements of the cell temperature to ensure the battery does not overheat or become dangerous. Before looking at the results, there were two different testing conditions. Both used identical Donut Lab solid-state battery cells. One setup used two heat sinks, and the other used just one. In the two heatsink setup, a single battery cell was placed between two metal heatsinks, one on the top and one on the bottom. A heatsink is usually made from aluminum because it is lightweight and very good at transferring heat away. The fins allow air to carry heat away from the battery, similar to how heat sinks are used in powerful computer processors. The battery cell temperature at the start of the test was about 23.4 degrees Celsius, which is basically room temperature. There was also a fan inside the testing system, though it is not clear whether it was used to actively cool the battery during testing or simply for safety in case of thermal runaway. Personally, the single heatsink test is more interesting because the two heatsink setup seems unrealistic. When these cells are stacked together inside a battery module, they will not receive that level of cooling. At CES, Donut Lab showed a prototype battery cell rated at 125 watt-hours. But in the report, the tested cell is rated at 94 watt-hours. That is not unusual because battery manufacturers often produce multiple sizes for different applications. According to Donut Lab, multiple cells will be combined into modules, and the Verge motorcycle will use several modules. If the cells are 125 watt-hours, it would take about 40 of them to reach a 5 kilowatt-hour module. If they are the smaller 94 watt-hour cells, then around 53 cells would be required. When the motorcycle is moving, airflow should help with cooling, but when the bike is stationary and charging, it may be more challenging. It is possible that a fan will be used to blow air across the battery modules while charging. The tested battery cell has a capacity of 26 amp hours and a nominal voltage of 3.6 volts, which equals about 94 watt-hours of stored energy. For comparison, one of the best batteries currently available is produced by Lion. That semi-solid state battery uses lithium, nickel, and cobalt chemistry. Donut Lab claims their battery uses abundant, geopolitically safe materials, which suggests that it likely contains no cobalt and possibly no nickel, and may not even be lithium-based. The voltage range of both batteries appears similar, which is a good sign. Some battery chemistries suffer from large voltage drops during discharge, but that does not seem to be the case here. The Lion cell has an energy density of around 305 watt-hours per kilogram, which is already very high. Donut Lab claims their battery can reach about 400 watt-hours per kilogram, meaning more energy stored for the same weight. Now, looking at the charging test results, the most realistic condition is the single heatsink test. In the 5C charging test, the battery went from 0 to full charge in about 735 seconds, which is a little over 12 minutes. C rate refers to how many times the battery can theoretically charge in 1 hour. A 2C battery could charge fully in 30 minutes, while a 5C battery can charge in around 12 minutes. During this 5C test, the battery temperature reached a peak of about 62 degrees Celsius. For traditional lithium-ion batteries with liquid electrolytes, this temperature would be concerning because temperatures between 60 and 80 degrees Celsius can lead to damage or thermal runaway. However, Donut Lab says their battery is different because it is a solid-state design. The researchers also tested an even faster charging rate of 11C, which means a full charge in roughly 5.5 minutes. Under this extreme charging condition, the single heatsink test reached a peak temperature of about 89 degrees Celsius. The first attempt was actually stopped when the battery hit 90 degrees because the laboratory has safety policies preventing tests from going beyond that temperature. For a traditional lithium-ion battery, this temperature would be extremely dangerous. But Donut Lab says their solid-state battery can safely tolerate it. The independent testing lab also reported that no thermal runaway or dangerous events occurred during the test. The remaining question is how repeated charging cycles at these temperatures will affect the long-term lifespan of the battery. That information is not yet known. There is also the question of how the surrounding components of the motorcycle will handle the heat because the body panels and structural parts also have temperature limits, and the rider is sitting right above the battery while it charges. In summary, the independent test results show that the Donut Lab battery cell can charge at extremely fast rates up to 11C without catastrophic failure. However, these tests were performed on a single cell, and it remains unclear how multiple cells stacked together inside a module will behave thermally. Donut Lab plans to release additional laboratory test reports soon, so this is only the first step in verifying their claims.